Okay, from Heng Yijia, good morning. For your attendance, we will use the attendance generated from Zoom, so do not need to fill anything. But we will have a feedback form at the end of the session. Then I will give the link. Okay, so it's 10 o'clock now. So I will start my introduction. Okay, good morning, everyone. I'm Lee Won Xiang from Utah. I'm also the KLESF Secretariat. Welcome to today's webinar, Engineering as Your First Choice. Thank you for taking your time out and being here today. In case you get disconnected, please join back using the link. We also will have a Q&A session at the end of the webinar. If you have any questions, just leave it at the Q&A box. Okay, the objective of this webinar are first, to generate interest in secondary school students to pursue tertiary education in engineering field. Second, is to provide insight on life as an engineer through this sharing session with engineering graduates. Okay, today we will be looking at the following question that you may wonder, such as, why should you choose engineering? What is the job prospect as an engineer? Engineering is a tough field, is it true? Join this session to know why you should choose engineering as your first choice. Acquire information related to engineering field to help you to choose your career path. Okay, so let's break the myth of the engineering during this session. Now, I would like to introduce our speaker. We have two speakers today. First is Dr. Gobi Kanadasan. He is an assistant professor at Department of Petrochemical Engineering, Faculty of Engineering and Green Technology, University Tunku Abdul Rahman, Utah. Second speaker is Mr. Lee Wei Hen. Mr. Lee, he received his Bachelor of Engineering Petrochemical Engineering from Utah in May 2020. He is currently a network design engineer in Huawei. So now, without further ado, we will turn the time over to Dr. Gobi and Mr. Lee. So, okay, Dr. Gobi, thank you.
Okay, thank you, Ms. Lee. Okay, good morning, everyone. So, my name is Gobi. I'm working as an assistant professor in Department of Petrochemical Engineering in University Tunku Abdul Rahman. And we have another speaker, Mr. Lee Wei Hen, who's also a graduate of Petrochemical Engineering. So, without delaying further, I would like to share my screen regarding today's presentation. So I can see here about 28 attendees. So if you have any question, please feel free to ask. I'll try my level best to answer your questions. It hopefully will be beneficial for you in terms of choosing engineering as your career path. Okay, let me share my screen here. Okay, you all can see the screen, right?
Yes, Dr. Gobi, the screen is good.
Okay, thank you. Thank you, Ms. Lee. Okay, first of all, I would like to give you some idea about what is engineering all about. Later, we will have a sharing session with Mr. Lee. So, as a first-hand experience, he might be able to share what kind of things he has gone through his 4 years of engineering degree, then his current work life, and so on. So, okay, let me go into this engineering as your first choice as the topic for today. So first of all, I'm sure some of you will be wondering why we need to go for this, because we have to understand some of the misconceptions we have about engineering is distracting the students from joining the engineering field or engineering course. So I just want to give some idea about the engineering, what is it all about and so on, so that you'll be better prepared when you're choosing your career path. Okay, first of all, you have to understand what is engineer, who's an engineer, okay, what is an engineer, who's an engineer and so on. So there are various definitions of who's an engineer and so on. So before you, um, without you knowing the role of an engineer, or without knowing the work nature of an engineer, you can't decide, or you there will be sort of misjudgment about the engineering field. So first of all, you have to understand one thing is, from where does this engineering field come from? You have to it is a mixture of science and mathematics. So basically you will be applying the knowledge of science and mathematics through in the engineering field. So you'll be equipped with the science and mathematics knowledge throughout your bachelor degree. And when you're learning about, when you're enrolled into the engineering degree, all the courses will be based on science and mathematics, almost like 85%, or yeah, 85%. Whereas the rest of the 15% will cover about the um, economics, social studies, and so on. But the core part of the engineering will be on the science and mathematics. And the implementation, or the usage of this knowledge, is called as the engineering field. Is the engineering field. Okay, first of all, what does an engineer do? There's a famous quote that scientists dream about doing great things, engineers do them. So what is it? What is this? What is so great about it? First, you have to understand, anyone can generate a brilliant idea. Okay, any idea could be very brilliant, but at the end of the day, it has to see the light at the end of the tunnel, where it has to come out as a product. So who does the transformation job? Who does the transformation from an idea to become a reality, or to become a product? It's all about the engineers who to make it happen by various means and so on. So the basic, I hope you understand what a role of an engineer now is. Basically a transformation of a guy who transform an idea to the product. He helps in various nature, so that the idea can be brought up as a product. And for him or her to do that, ample of knowledge is need to be acquired before you can implement that the transformation from idea to product, because there are various restrictions, there are various demand that or various conditions that has to be met before you can fully transform the idea to a product. Well, you have to understand the the transformation of the society at the moment. As you can see the slide here, we have been transforming from primitive society to agricultural society, to industrial society, then commercial society, then information society, then intelligent society. We are at the moment of is in the big excuse me. It is in between information society and intelligent society. As you can, as you know now, almost every one of us are having handphone. So all the knowledge, all the information is easily accessible to us. Various sources are available. We are not only depending on one source now, but there are problems coming attached to it too. For example, the authenticity of the information is not verified and so on. So we must have something to filter out those informations coming to us. And that's where the intelligent society will come into the place, where in the intelligent society, um, the ability to filter out intellectually, to process the data intellectually, will help out in the future generation and future transformation and so on. So for us, for me, as you can see here, the transformation is happening without the engineers. You can forget about, you can take out certain transformation that I talked about. For example, the information society or the commercial society, or even the major impact would be the industrial society. Without the engineers, you can basically remove this industrial society, commercial society, information and intelligence society altogether. You can wipe out altogether. So it shows the importance of engineers in industrial society, then, and the rest of the transformation that has gone through. But is it relevant today? Is the engineers relevant today? The answer is yes. Why? Because you just imagine a world without engineers. You would be still counting, is just an image here, as you can see. You can see the computation. For example, if you're calculating something, it can be easily done using computers. There are various softwares that can do the work for you. And of course, you are talking about the communication from one place to another place. For example, someone staying in UK wants to talk to someone in Malaysia or someone to Australia. It can be easily done by the means of handphone, WhatsApp, and so on. Can you just imagine without these softwares, how could they be communicating? It's like going back to the primitive days where the people will be sending birds, pigeons to send notes and so on. So it's all about the idea that come up of someone's idea that the transformation is needed from the from idea to the product. So you have to know that necessity is the invention of is the mother of all inventions. The necessity, because there is a need for you to create something. That's why all this come across. For example, you want to travel from somewhere, from one continent to the other continent. You find the means of the transportation. You want to know what are the availability. Then someone comes with an idea that when you go by air, it can save a lot of time and so on. So that's where the aeroplane comes in and so on. This other kind of, it starts with a small idea. That idea will be later transformed into products and so on. And to do this, that's where the engineers come into the picture. Okay. For example, here, I just would like to give you some idea who is an engineer all about. You have a house here. It's a common house, any house. Let's take out the engineering element out of this house. What would be the remaining part of it? It would be just logs, just cements. Then you have bricks. You can actually further break it down. For example, the cement, you can break it down to further like clay and so on. So even if you want to build a house, there is an engineering element into it. There is a calculation. There is a method of building it and so on. All this will be implemented or will be learned in engineering degree. So for example, building a house is basically about civil engineering. And of course, you have architectural element into it as well. So these are the things that you have to understand in almost in every things that we are dealing with on daily basis. There is an engineering element of it. Another example that I could give is the water filter. You have a water filter. Again, if you remove the engineering element out of this water filter, probably we would be drinking water, the clean water, drinking water from the river straight away. Just look at the color of the drinking water. Okay, if it's take straight away from the river that we have. It might be you might be drinking a polluted water, or you might be drinking very murky water and so on. So with the help of filtration, you can get a clean water. So how do we construct a filter? What are the engineering elements, or what are the features that need to be there in the filter? That's where the engineering knowledge is all about. You learn about what are the things needed to become to put together as a filter so that you can get a clean water supply. So these are the things where I just want to show. And as you can see here, um, in the past about 50 or 100 years, let's take about 100 years, we can see an exponential growth of the technologies. Exponential growth. I'm sure that for those who have idea about the graph, you have learned about the exponential term. Exponential, as you can see here, it is not a plateau, it is like very sharp increase of the technology. As you can see here, there are for at least about 100 years, you can see the various things has come into our life. For example, 3D chip, 3D movies, YouTube, hybrid cars, cell phones, Windows, and all these are things have come into our life. Before that, it is much very plateau stage where the introduction of technology has been very progressive or very slow, whereas for the past 100 years it has been rapid. It has been rapid, and we have to cope up with this technology development. And all this could be only possible if there is an engineer behind that. Without the engineers, there wouldn't be any driverless car. There wouldn't be any Windows, for example. There is someone who's doing the work behind this, all these things. So, for example, the growth of last time when we used to see hard disk in let's say in 90s, with the or let's put it in 2000, the size of it is just about 1 GB. The hard disk, I'm talking about a hard disk in a PC. Whereas now we can get the pen drive with a size of, some of it has gone up to 1 TB. So how is it possible? It is the evolution of the technology, and it is assisted by the engineers behind that. Okay, the first thing you should be asking is why you should become an engineer, or you can ask yourself why I should become an engineer. The answer lies in the direction of the world today. Okay, for example, we have seen various industrial revolution over the period of years. We have learned this in history, I believe, where there is a first industrial revolution, which uses the steam and water to do all the works, where the steam power is generated to power up the engines and so on to do the work. Later, with the help of labor and the electrical energy, a lot of things was done in a mass production. That is the second industrial revolution. Then the third industrial revolution came across when there is a use of electronics and IT system, where people start to use the robotics. The companies started to use robotics to do the to produce the product and to come up with the idea of new things and so on. And now we are in fourth industrial revolution. Okay, industrial revolution 4.0. So in that case, we need to equip ourselves with the knowledge so that we will be ready for the fourth industrial revolution. So what is this fourth industrial revolution? Basically it's about cyber physical system, where the smart system will be working, and the systems will be communicating with each other, and decision will be made based on that. So what are the things? So who is needed for this industrial 4.0? we need knowledge workers with growth mindset and empathy. So this is the major reason why the engineers are needed in future. You may argue that robotics has taken over our jobs and so on, but it's not true entirely. For example, in this one, there is an, as you can see, the one of the newspaper articles. Malaysia, I'm talking from the perspective of Malaysia. So probably if someone is from other countries, probably you can relate to your country's context. In Malaysia, we need about 500,000 scientists and engineers by 2020. This was published in 2018. So where do we stand now? We have only 170,000 registered under Board of Engineers Malaysia. So there is a gap. There is a gap between the need, the supply and the demand. The demand is about 500,000, whereas the supply is just about 170,000. There is a huge gap there. So the engineers are actually in dire need, but we do not have enough engineering graduates who's willing to or who's working in the engineering field. So it is not true that engineering you won't get a job as an engineer and so on. We are actually looking for an engineer. The companies are looking for an engineer who's willing to work to realize their mission of their corporates and so on. Okay, why you should become an engineer? Okay, first of all of us are motivated by financial rewards and so on. Here we have just giving an example for a freshie. An average, we are talking about average. There are various fields of engineering. So we are talking about the average. When we talk about the average for a freshie, you can get about 3,600. I'm talking from the perspective of Malaysian context. Ringgit Malaysia about 3,600 as your first salary. It could be some of the companies are offering about 3,000. Some are offering 4,000 also have. So these are the range of salary, and approximately the average is about 3,600. So it is a good motivation. And if you are for a start, 3,650 is a good money for a start. I'm talking from zero experience. Once you grow in your engineering field, you grow up the ladder. Eventually, by the 10 years of experience, you can go 5 figures. Your salary could go into 5 figures. In some of the cases, there have been cases where it has gone into 6 figures. So basically, if you are motivated by the financial rewards, engineering is one of the great field. And of course, you have to remember, once you learn to become an engineer, you can start your own engineering firm and so on. So it's basically about a business perspective from there on. So it's not talking about just a monthly salary. It's more about your own business based on the engineering field. And the exciting part is the challenges that you face every day. Sometimes there are various needs from the customers. Some customers requires different perspective, different demands, and so on. So when you see an engineer, normally will be working with new projects, exciting challenges. He normally won't be doing the same thing all over again and again. So he might be looking into new things, exploring new things, and so on. And it is a part of human cycle as well. You continue to learn every day. You just don't implement the ideas you have learned about 4 years back and so on. So you evolve together with the demand of the engineering field. For example, probably whatever you have, when you first join a company, you'll be asked to work on a project. You use that knowledge that you gain in the first project to be implemented in the second project. Then it goes on and on, the chain reaction. That's where I'm talking about the challenges. So the challenges will be new. some elements could be learned and so on, so to be taken forward for the next challenge and so on. And if you are you have to understand, as an engineer, you do not work individually, you work as a team. There'll be various engineers coming from various fields. For example, in a project, there could be chemical engineer, there could be a petrochemical, there could be a mechanical engineer, there could be electrical engineer working together to solve a problem. So it's a place where you can make your network to grow as well. Then you have, as I told you just now, the high demand. The IR 4.0 demands more engineers in future. So that's where the motivation why you should become an engineer. As I told you, financial challenges, network, and the demand is always there for you to become an engineer. So think these are the things that you have to think carefully here before you can decide on your future. So who should join? So who is the suitable person to join the engineering degree? This one I'm talking from the perspective of industrial psychologists. People have the psychologists have reported on the they have studied the engineers, and they come up with an idea who's an engineer is all about. Basically, engineer, if you want to become an engineer, it is you need to be curious. The curiosity must be there, and you have to be always want to know how does it work and so on. So for example, if you are a fan of there's a TV program called How Does It Work, how it works and so on, how things works. So if you're a fan of that program, that means you have some sort of curiosity to know what is happening, how does it work. For example, how the train is being built, how tower is being built, or how the, for example, for today's case, sanitizer is being made, and all these things. If you are keen to know the process, that means you have a high curiosity in knowing things. So basically, without you realizing, you have actually the engineering mindset in you. And of course, you are always excited to learn new things. That's where the engineer is all about. You always progress and progress and progress. So that's one part. And the other part is, if you are visionary, if you like to think what could be in future, probably someone could have dreamt in the 1990s that cars can be self-driven. It is possible today. So how does it? How does the transformation take place? There's someone who has the vision to see that car can be self-driven, and it has made into reality today. How is it possible? It is possible through the sensors and so on. So if you have a futuristic idea about things that could be in future, then it is a good thing that it's a high time that you should join engineering as your career path. Then if you are a dynamic person, love to try new things, accept new things, and be open-minded, and I think it is very much suitable, or your mindset is very much is an engineering mindset. So you just have to love to be try out new things, experiment new things. That's where a lot of things come across. Some of the things found accidentally, okay, and it has made millions and so on. Okay, now, of course, when you're talking about the engineering, you talk about the job prospects. First of all, you have to understand what are the major 4 different fields you have for an engineering. You have chemical engineering, you have electrical engineering, you have mechanical engineering, then you have civil engineering. These are the major 4 fields of engineering. There are a lot of sub branches under this engineering. For example, when you talk about electrical engineering, there are, of course, electronic engineering, there's a communication engineering, then there's a power engineering, and so on. So basically, electronics engineering, you deal about chipset production and so on. Communication is more about research and development and giving a design for the new communication tools, new satellites, and so on. Then you have a power station. Basically, you deal with the power supply from one place to the other place. And of course, there are a lot of R&D involved as well. Then you have the mechanical engineering. Of course, you have when you say the mechanical engineering, the most thing that you can come across is the engines. You're dealing with engines. Of course, you're design and manufacturing engines. You have to improve the engines all the time to meet the demand of the customers and so on. Then, of course, the turbojet. You're talking about the aeronautical engineering as well. Aeronautical engineering, sometimes it can be categorized as under the mechanical engineering, or it can be standalone by itself. And in aeronautical engineering, you learn about how does the aeroplane works, how to improvise the design and so on. Then you have robotics, and it's basically is about handling industrial robots. The major motivation for the industrial people to use the robotics is about precision. So it is a very precise work by the robots if they are implemented in the mass scale. Then you have civil engineering. In civil engineering, you have geotech, where people study about the engineers study about the earth materials. Then you have civil engineering that deals with buildings. It can be buildings, it can be bridges, it can be houses and anything. Then you have highways, road or highways, so we can just group it together, road or highways, where they learn, the engineers design the roads, the highways and so on. So this is about the civil engineer, who is a civil engineer is all about. Then you have the chemical engineering. In chemical engineering, you have petrochemical engineering, where you deal with polymer production, soap production, fertilizer, paint, and all those things. Then you have wastewater treatment, where you learn about the wastewater treatment as well in the chemical engineering, and you can become a wastewater engineer. Then you have pharmaceutical industry as well, pharmaceutical engineer, pharmaceutical field as to be exact, where the production of medicine can be categorized or can become under the chemical engineering field. And of course, this chemical engineering field is a very broad field. And since I'm from the petrochemical engineering, probably I can talk further about some petrochemical engineering thing, in which when you break it down further in petrochemical engineering, you can work as an engineer in petroleum refinery. Then you have in glove industry, then in polymer industry as well. And so these are the job opportunities available for you. For example, you have Shell, YTL, Gamuda. It is not specific for one field of engineering. I'm talking about various fields. I told you there are 4 major fields just now: civil, mechanical, chemical, and electrical. So these are the potential employers who are reputable employers in Malaysia and overseas as well. So it is not limited to this. There are various more companies who are willing to, who's in dire need to hire engineers. So the opportunity is vast. So you should make use of this to become an engineer and progress in your career. Okay, engineering is tough. Is it true? Some people complain that, oh, no, engineering is tough. I don't want to go into it. It is actually not. It is not true. Okay. The answer is no, it is not true, even though some say it is very hard and so on. What are the things that you need? First of all, you have to be open-minded. Okay. you have to be open-minded in receiving new ideas, receiving new information. Okay, you have to be open-minded about that. If you are a very closed-minded person, then it's a bit difficult. But if you're very open-minded to accept the new challenges every day and so on, you're a very adventurous person, then engineering is the field for you. And what you have to do is you have to stay focused when you're studying your engineering, because every knowledge that you gain from engineering during your engineering degree course, eventually it will be implemented in the real field. You'll be learning the basics in undergraduate studies. When it goes to the real life, you'll be implementing at the much bigger scale. And you have to understand one thing, that's one major thing. You will work in a team. So it is a teamwork. It is not just about you taking the decision all the time. So it will be assisted by a lot of factors. So it is much more guided. So just that you must equip yourself with the basic knowledge of engineering. If you equip yourself with the basic knowledge of engineering, that's good enough for you to progress in your career. So why we are busy talking about engineering as your first choice? First of all, we want to be inventors, not merely users. Okay, as you can see the picture of a pen drive here, it is actually invented by a Malaysian. Not many people know about this history, but there is someone who had the idea of transforming a huge hard disk into a small size pen drive. So the idea has been transformed into a product now. How is this possible without the contribution of engineering element into it? There is an engineering element into it where the electronic system is involved, where the mechanical part is involved, and there could be some chemical engineering as well involved, because you're talking about the soldering part, you're talking about the etching part and so on. Then you could be talking about the probably civil engineering is not involved here, but the other elements are involved. The software engineering also is being involved. So instead of just becoming users, we want someone to invent new things for the future generation. And with the knowledge of engineering, you will be much equipped to invent new things which can be beneficial for the future generation. So that is the reason why we are stressing upon you have to join engineering field and make yourself or make a path for yourself to become inventors in future. And of course, you can become a businessman as well by using the knowledge of engineering that you have learned. It is not about stagnant. The engineering field is always dynamic, but the important thing is the knowledge that you gain as an engineer. Okay, we have seen a lot of things in recent years. We call it as disruptive science and technology innovation. What is the disruptive science and technology innovation? Is basically about moving away from the norm, the mainstream ideas, mainstream things that we have at the moment. For example, we have a self-driving car. It is not imaginable about 50 years back. And then that's what we have a Tesla. Then you have 3D printing. Then you have smart traffic system. Hold on. Then you have a smart traffic system. Then you have big data analytics. Then you have SpaceX reusable rocket and so on. And people talk a lot about the big data analytics and so on. Basically, now we have, as in the information age, we have a lot of information to us. We have to, it is very much cluttered. We have to organize it. We have to filter out the information that we have. Then we can process it to become a product that we want, or to the information that we need for a certain things. So basically, big data analytics is about processing the data that we have in a very systematic way, so that the information needed for that particular field or particular technology can be used and so on. So what are the challenges in the 21st century? Of course, you have various challenges. You have, first of all, the basic necessity is to provide access to clean water. You have to find ways. The engineers are constantly moving towards finding new ways to provide clean water to the people, because in some areas we have lesser accessibility to clean water and so on. Then we are talking about the advanced health informatics in COVID-19 situation. This is one of the important elements that we are talking about. Then we are talking about the enhanced virtual reality and so on. So these are the challenges that we have. I've picked some from here. There are various things, as you can see here. Of course, the providing energy from fusion, from solar heat panel and so on, because we are talking about sustainability as well. Together we are binding the sustainability together with the engineering nowadays. Sustainability is basically about we are sustaining things for a longer period of time without disrupting the environment and so on. So these are the things that you have to take into account while you are learning engineering and for during your degrees life as well as in your working life. So thank you. That's all from me regarding the sharing session we have regarding the engineering field. So I hope that you have gained something. You have gained some knowledge about what is engineering field is all about, who should join, and so on. So this is since I'm coming from Utah, I can probably share with you the campus experience we have. For example, we have plenty of a proper campus in Utah Kampa. So please have a do pay a visit to us so that we can bring you around the campus, and I'm sure that you'll be very much attracted to study in engineering in Kampa campus. So hope to see you guys. For those who are very much interested in engineering, we welcome you with open arm. So that's it from me, and thank you and have a great university life. And just reminder for those listeners here, please stay safe and practice the hygienic practice. So that's it from me. Thank you. Okay, probably I can have some open discussion with Mr. Lee first before we proceeding to answer your questions. We have a few questions here. Thank you, Mr. Lee, for joining us today. He's an engineer in Huawei. So probably Mr. Lee can share us the 4 years experience that he had in Utah Kampa.
Okay.
How is the experience and so on? So Mr. Lee.
Okay, good morning, everyone. Okay, first of all, I would like to share with you that if you don't like maths and physics and the science study, you better don't take the engineering. And in case that you didn't do it well, yes, you can make it better by learning. Okay, if you don't like it, then just don't consider engineering, because actually, from my point of view, engineering is not difficult, but it's actually not easy. So it's based on you how you treat it. Okay. I have several tips to share with you all based on my previous 4 years of experience. Okay, first of all, always make a plan. Okay, in advance before the starting of the per week or per month. Like you can plan out the lecture, tutorial, the labs and experiments, and all the tests and quiz. Always make a plan before everything, and definitely you need to prepare according to your plan. Like this is a very important point, and do not do last minute work, because usually the last minute work is not that high quality. And for example, like you can always look through the materials before you're entering the class to get a better concept, so you won't like totally get no idea at all what the lecturer is talking about. And after the class, you can make a short review or a short revision. As the memory is still fresh, okay, you can absorb it easily. You don't need to like before the test, you need to study everything again. And I want to say that uni life is not just about study. You can always try to join activities. There's a lot of activities in the university, such as the club and societies, and a lot of the volunteering program locally or globally. This is because you can make a lot of friends, you can learn new knowledge, and you also can broaden your vision and experience. I think this the not everyone see this value that you can get in your university life instead of knowledge. I think this is the conclusion for my 4 years engineering life.
Okay, Mr. Lee, probably you can share about um, the work life once you graduated. How do you transform or how do you implement the ideas that you have learned in engineering degree to your work life?
Okay. Okay. Before that, I want to share that I'm just a fresh grad. I graduated on May 2020. I enrolled into Huawei in 2 months ago, and I'm holding a position of network design engineer. And currently, I'm in the Department of Asia Pacific, and I will be in charge of the telecommunication setup in the Asia Pacific countries, including the 4G and 5G infrastructure. Okay. At this moment, I have not much to share because I'm still in the stage of self-learning in order to prepare for my upcoming professional training. So, because I'm from a petrochemical background and now I'm in the telecommunication field, I actually realized something that it's important that what you study and what you do, but it's not definitely that like you doing chemical, you must working in the chemical field, because the thing that we learn in the years is actually the for engineering mindset, because like engineer can slightly study things more effective and more organized. I believe that it's due to the practice of engineering thinking since the day one in the degree. And because how to say, I will try to during the self-learning, I will try to practice to clarify the main concept of the thing. Then I proceed to the smaller scale, and I will make a simple conclusion for each topic. So it actually applies to everything, no matter what kind of background you're doing. So I will clarify it as an engineering mindset, because engineering usually we learn how to think in order to solve a problem, because we need to approach to different solution and we'll find the best one. So I think it's actually a very important thing in engineering. Okay.
Okay, thank you, Mr. Lee. I think he has shared some very valuable point there, where you are learning things and you are applying it, not necessarily in the same field, but the knowledge that you gain, the basic knowledge, the fundamental knowledge that you gain during your engineering degree time will be useful when you implement it later. It can be in the same field of engineering, it can be in different field of engineering, that doesn't matter. But the engineering mindset, as highlighted by Mr. Lee just now, is very important things that you can learn from here. Okay, I think we have a few questions here. First question is coming from someone asked about the someone asked about the environmental engineering. Okay, environmental engineering is basically you study about the environment, how you preserve the environment, how do you analyze the environment, how do you do things to the environment so that it won't be disruptive to the whole ecosystem and so on. How do you treat a wastewater? All these things will be learned in environmental engineering. So it can, as a subset of chemical engineering, but it can be, in some cases, it is a standalone by itself. But most of the things that you learn in chemical engineering will be implemented in environmental engineering. To a certain extent, environmental engineering and civil engineering are chemical engineering and environmental engineering, sorry, chemical engineering and civil engineering, both will be contributing towards the environmental engineering. Okay, so I hope I answered your question, Zihong. And open question we have, how do you recommend mechatronics engineering in its career? Okay, mechatronics engineering, as you are supposed to be aware that it is a hybrid engineering in which it is a combination of mechanical engineering and electronics engineering. So you'll be learning both of mechanical element as well as electronics element, and it will be useful in learning in applying it in robotics. So in that sort of field, robotics kind of field, and this kind of engineers can be employed in major industries. For example, Proton, for example, Toyota, all these big players where they use the robots to manufacture the car and so on. So these are the opportunities available for you in mechatronics engineering. 3D printing industry, especially in Malaysia. I see, okay, Mr. Ki Zitian. Yes. As you know, in recent years, 3D printing has grown in kind of exponential phase as well. You have to remember, in recent years, we have seen a lot of things being printed in 3D. For example, we have seen printing of membranes, printing of, in recent years, I've seen they print a ship or a boat using 3D printer. So all this possible. In the Malaysian context, we are in the growing stage. We are not implementing it in full yet, but we are starting to implement things using the 3D printing. But it is a good future, considering the fact that a lot of things can be done. A lot of things can be done through the 3D printing. Okay, someone asked about the, I hope it answered your question, Zike. Then I have a question about computer engineering. Computer engineering is basically about you're dealing with computer networks. You try to develop new things. Software engineering can be kind of categorized under this. So you'll be developing, you'll be learning about the coding and so on. So of course, the demand is always there for computer engineering because, as you know, Industrial 4.0 demands the knowledge-based engineers. And of course, the brain behind the robots would be a human being. And that human being will be basically has the knowledge of computer engineering. It could be mechatronics engineering and all those things. So computer engineering has a good future. In Industrial 4.0, they will play a big role because eventually the communication is a big tool in computer engineering, as well as in the Industrial 4.0. So eventually they will be overlapping each other, and you can see the importance of computer engineering in future. So any other question that I could answer? So we have various participants here. Probably you can ask questions so that I can try to answer your questions. Okay, Junwei Ko, thank you for your question. I want to get into automotive industry. Okay, would chemical engineering provide me a path to that industry? Yes, it can provide a path to that industry. It is not exclusive for the mechanical engineering alone, but depends on what is your interest. For example, if you are interested in the engineering, in the design of an engine, design of of a car, and so on, then it is suitable for you to do the mechanical engineering. If you're talking about the fuel efficiency, if you want to create a field or you want to have an idea about creating new fuels for future, you're talking about new formulation and so on, then chemical engineering can play a role or can pave a pathway for you to go into the automotive industry. For example, F1 industry, there are a lot of chemical engineers working in that particular F1 industry. Why? Because they are dealing with improvisation all the time in terms of fuel efficiency and so on. So it is not limited to, or it's not exclusive for the mechanical engineering alone to be in automotive industry. Just that even if you go into chemical engineering or petrochemical engineering, it can pave your pathway to the automotive industry. Any other question? I think we still can entertain a few questions because it's your career. You can ask questions. You can equip yourself before deciding. That is most important thing, because when you are choosing your career, you have to be very careful, and before choosing, you have to equip yourself with ample of knowledge, because wrong choice would lead you to miserable university life. So please make sure you ask questions if you want to ask. Okay, do I have to further maths in A levels to study engineering? Yes, Nicholas. Mathematics is an important element for engineering. So you have to take maths in A levels to study the engineering. Eventually, when you come into engineering as well, engineering degree as well, you'll be learning about advanced mathematics and so on. Okay, what's the difference between chemistry and chemical engineering? Okay, basically, chemistry is about finding how does the two things work together. For example, let's say you're talking about sodium, then you have chlorine. When you mix this sodium and chlorine, then you have a product of sodium chloride. That's the um, that's the understanding where you gain from the chemistry. But to produce that sodium chloride in mass production, you cannot simply mixing 1 kilogram of sodium and 1 kilogram of chloride mixed together, you can get a sodium chloride. No, it doesn't work that way. That's where the chemical engineering comes in. Chemical engineer will decide on what are the equipments needed to produce the sodium chloride in a major scale. There will be a lot of, I'm just taking an example of the sodium chloride. It could be hydrochloric acid, it can be sulfuric acid, and so on. Chemistry wise, you can find the reaction between component A and component B. When they mix together, they will produce component C. You will know that. But how to produce it in mass scale? That's where the chemical engineers will do the job. They will produce the required product in a large scale with proper equipment, with proper conditions of the reactions and so on. So there are various factors involved. For example, in a plant, you have a reactor, you have heat exchanger, you have pumps, you have distillation column, all this. the chemistry knowledge, chemistry-based people would not know how to operate the reactor. He or she wouldn't be able to know how to operate the heat exchanger. He or she doesn't know how to operate the pumps, how to buy the pumps. When you are building a plant, you have to buy a pump to install, for example. The chemistry people won't do that or won't know about that. Whereas for the chemical engineering guy, would be able to understand the nature of the process, and he will be able to design the entire system and know what are the suitable pumps or suitable heat exchanger to be installed in that particular plant so that the products can be produced. Cheesing, yeah, I hope that I answered your question. Any other question? It's a high time that you can ask question, because eventually you will be deciding for your future. So please make sure that you ask questions. Do physics and additional mathematics play important role in further study in engineering? The answer is yes. Okay. The answer is yes. Because the elements of engineering comes from the field of physics, and to do the calculation, the additional mathematics is the fundamental knowledge. That's where you learn about integration, you learn about differentiation, all those things. In physics, you learn about the basic things, for example, Newton's law, and so on, so many other things. So that those are the important elements that you will carry forward for your engineering field. Any other questions? I welcome questions because it will be very helpful for you to know where do you stand or in choosing your career.
Hi, Dr. Gobi. Miss
Okay.
Lee here.
Yeah.
It's about the time now is 11:02.
Okay.
So probably we wait for another minute to see any question.
Okay.
So while waiting for that, I would just like to inform that we have prepared a feedback form. So for all the participants, we appreciate if you could help us to fill up the form after the webinar. So I just posted the link. Hope that you guys can help us to fill out the feedback form so we can improve.
Okay. Okay.
So yep, there's one more question, Dr. Gobi.
Yeah. With internal combustion engines getting phased out by electric vehicles in the future, how would it affect the mechanical engineering? Okay. We can see this from various perspectives. At the moment, we are just talking about electrical vehicles in the on the road, whereas you have various other vehicles as well. For example, aeroplanes. You have aeroplanes. Then you have so many other heavy industry vehicles where the electrical element is not important or it's not significant at the moment. But at the same time, mechanical engineering is not all about just about engines as well. It's about the design of the cars, design of the what do you call this? Design of the vehicles and so on. And you have to understand another thing is, even though it runs on a electrical system, at the moment we are talking about a battery, where the battery generates the power to certain part of the car, certain phases of the travel and so on. And it eventually depends on the engines to do the work later on. So don't limit yourself to the electrical vehicles, or mechanical engineering is all about just engines. It's beyond that. Mechanical engineering can involve the design of the car and so on. So it's just not limited to the design of the engine alone. So combustion engine, of course, it might get phased out, but at the moment in heavy industries, the implementation of combustion engine, internal combustion engine still exists. So it cannot be dismissed altogether. Okay. Okay. Based on your perspective, which field of engineering is more demanding or has brighter future for Malaysia's market? Okay. To be honest with you, I can be a little biased here. Okay, because I would say petrochemical engineering is one of the demanding engineering in future, because the evolving technology has brought up a lot of new possible avenues for us to explore with the petrochemical engineering, where you produce new things all the time and so on. For example, you see the evolution in the paint. In those days, paint is just about buying a can of paint and paint it over a wall and so on. But today we have plenty of choices in terms of catering respective needs. For example, you want to be antifungal, you have a certain type of paints. You want to be outdoor paint, you have certain types of paints. How is this possible? Is this possible because the evolution of the knowledge in the petrochemical engineering, where you implement the idea of using the polymers into the paints so that it can be painted and it can be used for a longer period of time. So the elements of polymer has gone into the paint, and a lot of things gone into it as similar to this. And similarly for the industrial 4.0, as I told you just now, the robotics element has a very big role to play. So you can go into the mechatronics kind of engineering, or the those sort of engineering. And we are talking about sustainability as well in recent days. In sustainability, we're talking about how to sustain. When you produce a thing, it has to be sustainable for a very long period of time. We have a sustainability assessment and so on. So in that case, the environmental engineering, the petrochemical engineering, the chemical engineering will play a role as well. It's basically, what is your interest? What is your interest? You have to ask yourself about that. So if you ask yourself, then I believe that you can see a future in it. Okay, since mechatronic engineering covers mechanical engineering mechatronics, is more demanding than only tracking mechanical or electronics engineering. Okay, okay. Let me tell you something, Jinwei. The thing is, mechatronics engineering is a hybrid engineering, as I told you just now. It's involved mechanical engineering and electronics engineering. But if you want to know the depth of this mechatronics engineering, it is not similar to the core mechanical engineering and the core electronics engineering. It's some sort of you don't go deep into both of these fields. So you'll get some element from the mechanical engineering, some element from the electronics engineering, you combine together. So the depth is not there as compared to mechanical engineering alone or electronics engineering alone. It's more about the breadth. Okay, so if you want to be a specialist, if you want to be a specialist in, for example, automotive specialist, then you can go into the mechanical engineering rather than going into mechatronics engineering. But if you are interested in robotics together with the let's say robotics in automotive industry, then mechatronics industry engineering would be a good engineering field for you. So basically it goes back to the question, what is your interest? So if your interest is in to become an expert in certain field, for example automotive industry, then go for the core subject, for example mechanical engineering. If you want to become expert in or specialist in electrical system in automotive industry, for example electrical system in a car, then you go for the electronics engineering, then you try to implement that in the automotive industry. But if you just want to, if you're interested about the robotics and so on, then you can go for the mechatronics engineering, but the depth is not there as compared to the core engineering subjects. Jinwei, I think I've answered your question. I hope it helps. Probably you can ask one question to the graduate here. Probably he can answer because he is the most closest to the students. Probably he can answer from a perspective of a student, what you can expect and so on. Any question to him? Okay, since there is no question, okay. Just give me a moment. Okay, someone asked me about what is the Miss Jagadish. What is the basic salary of engineering? Okay, basic salary of engineering can vary from for a fresh engineering graduate, it can vary from 3,000 to 4,000. That depends on the companies that we are going to go into. For example, if you are going into big companies, for example, Petronas, Shell, and so on, your salary will be in the range of 4,000, 3,900, that kind of range. So it's much on the higher side. Whereas on the normal companies, for example, you have mid-range companies, then your salary is about 3,000. That's the starting salary, the basic salary of engineering student. Once you graduate, the first salary is around 3,000. Any other questions? Hopefully that does help, Ms. Jagadish. Okay, we have Vaitat asking about it will be better to work in a small company to gain more experience. Okay, sometimes, yeah, it can be true, but at the same time, you have to understand if it is good that you can go into the big players or big industrial companies in the beginning itself, because the scale of the projects that you'll get in big companies is much larger. So when you're talking about a scale of the projects, you can learn a lot of things more in bigger projects. So your exposure will be more, but at the same time, it is not. It's a bad thing to join a small company first. In a small company first, you'll be in a small company. Sometimes you will be the jack of all trades. That means you'll be you will do a lot of things, and that means you'll learn a lot of things as well. So it's not just limited to just implementing a project. Probably you'll be doing, for example, when you're talking about doing a project, you have to do the cost calculation, you have to do the procurement and so on. So in this kind of things, in a small company, as an engineer, probably you'll be doing all this together. You'll be handling all these things. Whereas in bigger companies, there will be a respective department doing all these things. So that's where the difference lies. Apart from that, I don't see any difference in it. But of course, in a bigger companies, your scale of the projects will be bigger and your exposure will be bigger as well. Any other questions? Okay, if there's no further question, thank you. Thank you for your time. Thank you, Mr. Lee, as well for joining us today. If you have any questions, feel free to ask the Utah Secretariat if they can help you out. Probably they'll try to channel you to the respective lecturer or departments so that they can answer the question for you. Thank you once again for listening, and hope the sharing session today or the webinar today is helpful for you in choosing your career as an engineer. Okay. Thank you. Good luck for your future. And thank you, Mr. Lee.
Okay, thank you. Thank you, Mr. Gobi.
Thank you, Dr. Gobi. Thank you, Mr. Lee. Okay. Okay. Thank you everyone for attending. So we will end our session here. If you have any question, you may drop us email or Facebook page PM. We will pass the question to Dr. Gobi if you have any question.